inequalities in one triangle. So when we have a triangle, we've got a figure that has 3 sides and 3 angles. And there are certain aspects about the sides and the angles that are always true. For example, the longest side of a triangle is always going to be opposite the largest angle. And the shortest side of a triangle is always opposite the smallest angle, which is why in a right triangle, your hypotenuse is always the longest side. Now, the largest angle is opposite the longest side, and the smallest angle is opposite the shortest side. So if we wanted to find our longest and shortest side in this example, I would look and I would see that 65 is my largest angle. So that means that BA is going to be my largest side or longest side. And I have a feeling this is supposed to say largest angle. So change that to large angle, and our largest angle is angle BCA, or ACB. Now our shortest side is going to be across from our smallest angle. So as you can see, angle A, or angle BAC, is our smallest angle. So that means our shortest side is across from that is going to be BC. And when I say across, I mean it's the side that does not create the angle. So notice AB and AC create angle A. So BC is the angle that's across. Just like here, BC and AC created angle C, and BA is the side that's across from the angle. Alright, so we actually do have 2 theorems that work with that. If one side of a triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So if one side of a triangle is longer, then the angle opposite that must be larger than that of any leg that's shorter. If one angle of a triangle is larger than another angle, then the side opposite the larger angle must be longer than the side opposite the smaller angle. Alright, so let's do a few examples. Example 1. Write the sides of the triangle in order from shortest to longest. So I want to write the sides. So if I know this is 60, this is 60, and this is 62, then I know that this angle, angle A, must be 58 degrees. Okay? So now I'm doing the sides. So my smallest side, or my shortest side, is going to be across from my smallest angle. So side BC is the shortest. Okay? So I'm going to do small, medium, large. So BC is the shortest, and next is 60 degrees, and that's across from my AB side. So AB is my medium side. And then the last one, 62, that is my biggest angle, so it's across from my longest side. So AC would be my longest side. Now, similarly, it works the opposite way. Your largest angle is going to be across from your longest side. So if I'm writing these small, medium, large, my smallest side is TU. It's only 7, and it's across from angle V. So that means angle V must be my smallest angle. And then next is 10. 10 is across from angle T. So angle T must be my medium-sized angle. And 11, TV is the length of 11, which is the longest side. So that means angle U must be my longest, or my largest angle. All right. Now, in terms of the sides, there are ways in which you cannot create a triangle. It's not just arbitrary what the numbers are that can create a triangle. So if you look here, the sum of the lengths of any two sides of a triangle is greater than the third side. So that means if I add up any two sides, it must be greater than the third side. And if it is not, then you cannot have a triangle. So, for example, if I had triangle A, B, C, then I know that side AB plus side BC must be greater than AC. And similarly, AC plus BC must be greater than AB. So what you want to do, the easiest way to approach this, is to take the two smallest sides. So in this case, I've got 18 and 12. And you need to see if 18 plus 12, how does it relate to the third side, which is 27? Well, 18 plus 12 is actually 30, and 30 is greater than 27, so yes, this could be the side of a triangle. All right, this case I've got 5 and 7. Those are my two smallest sides. So 5 plus 7, how does that relate to 14? Well, 5 plus 7 is less than 14. 5 plus 7 is 12. So this cannot be a triangle, not a triangle. All right, 12 and 14. Well, 12 plus 14, how does that relate to 26? Less than, greater than, equal to. This is equal to, okay? It has to be greater, not greater than or equal to, only greater. So this, not a triangle. All right, 2.001, 3, and 5. Well, these are my two smallest sides, and they equal 5.001. And as minuscule as that might be, it is greater than 5. So therefore, D is a triangle. Now, the square root of 5, if you don't know what the square root of 5 is, then type it in your calculator and you get, it's about 2.25. So, and I mean, think about it. You know that the square root of 4 is 2, right? The square root of 4 equals 2. And you know that the square root of 9 equals 3. So the square root of 5 has to be somewhere between 2 and 3. But the only way you're going to get this to be a triangle is if this equals more than 3. And it doesn't. So this cannot be a triangle. Alright? So add the smallest two sides, see if they're greater than the larger side, the largest side. And if it is a triangle. If it isn't, it is not a triangle. Alright, well, what if we don't know what the third side is? What if one of the sides is just an x, and we need to figure out what possible values for x do we need? So what you can do is you can set up 2 inequalities. You can actually set up 3, but you really only need 2. So obviously, if I add 16 and 11, it has to be greater than x. So my first inequality is going to be 16 plus 11 greater than x. And when I solve that, I get that 27 must be greater than x. Okay, so x can't be 27 or higher. And then I need to set up a second inequality because that's my maximum, but I want to find out my minimum value for x. So what I'm going to do is I'm going to take the smaller of the two numbers, which happens to be 11, and I'm going to say x plus 11 has to be greater than 16. Okay? So when I solve this inequality, I get that x must be greater than 5. Now the third inequality would be to use 16, but then you wind up with a negative number, and obviously x has to be greater than a negative number. If it has to be greater than 5, then it has to be greater than negative 5. So now I've got my 2 inequalities, and I'm going to write a compound inequality to represent the possible values of x, or the possible third side. So take your smallest number, which is 5, it goes on the end, and 5 is less than x, and x is less than 27. Okay? So these are my possible values for the third side of the triangle. Alright, same thing in, I'm going to call this x, because right now it's just a question mark. But same thing on this triangle. So I want to come up with 2 inequalities. Doesn't matter which one you do first. I'll do x plus 7 first. So x plus 7 must be greater than 11, which means that x must be greater than 4. And 11 plus 7 must be greater than x, which means 18 is greater than x, or x is less than 18. So then x always goes in the middle, smaller number on the left, just like a number line, larger number on the right. So my possible values for yx are between 4 and 18. Alright, in example 5, we want to list the sides in order from shortest to longest. So in order to do that, we need to know all of our values. So I think this says 95. Maybe it says 90. All right, I'm going to go with 95. So 95 plus 30, and you take that away from 180, you get that this angle here is 55 degrees. Okay? And then here I've got 100 and 35. So this angle is 45 degrees. Now, a couple of these angles are going to overlap. These sides are going to overlap. So I'm going to do this triangle first. So I'm going to write on here and then I'll mark it out. But 95 is my biggest. So in this triangle, this is the largest, this is the smallest, and this is the medium side. Okay? Now in this triangle, this is the largest because it's across from 100. This is the shortest, and this is the medium. So if you notice, my blue triangle overlaps with my green triangle, so to speak. So that means my shortest side overall, out of both of these triangles, out of this whole diagram, my shortest side is going to be KM. Okay? And then next would be KL. And then next would be LM. And that's the longest or the largest of one triangle, but it's the shortest of another triangle. So from LM, because it kind of repeats, you don't have to write it twice, from LM being the shortest of triangle 2 to LN, which is the medium side, and finally to MN, which is the largest or longest side of all the triangles. So I had 5 sides, but notice here how these 2 sides overlapped. It was the shortest of one and the longest of another. All right, last example. I want to find the range values for x. So, same idea as above, just a little more complicated in terms of inequalities, but I know that AB plus AC must be greater than BC, for example. Okay? That's one inequality. So I know that x plus 2 plus x plus 3 must be greater than 3x plus 2. So this gives me, so when you solve for x, you should get that 3 must be greater than x. All right, so we're going to keep that in mind. That's part of it. All right, so I did AB plus AC is greater than BC. So now I'm just going to move down, and I'm going to say AC plus BC must be greater than AB. And we're just going to set up our inequality. So I've got x plus 3 plus 3x plus 2 must be greater than x plus 2. And we solve that out. And we get that x is greater than negative 1. Okay? Now, your x value can be negative, but your side length can't be negative. So keep that in mind. X is okay to be negative as long as it doesn't give you a negative side length. So we'll check that in a moment. All right, so I did AC plus BC, so now I'm just going to do my third inequality. BC plus AB must be greater than AC. All right, and so it's the same values for all the side lengths. I'm just shifting them, if you can tell. X plus 2 must be greater than X plus 3, which is my value for AC. And I solve this, and I get that X must be greater than negative 1/3. Okay, so this is when I need to take a step back and look at my three values that I got for X. Well, I know X has to be less than 3. So it's my smaller end that I need to be concerned about, and we're going to use X is greater than negative 1/3, because if X must be greater than negative 1/3, this constraint trumps this constraint, because negative 1/3 is larger than negative 1. Now, the other reason why we can't use negative 1 is because if you plug in negative 1 to each of these sides, here you would get 1, so that's okay. Here you would get 2, so that's okay. But here you would get negative 1. And since our side lengths cannot be negative 1, we're just not going to use this one. So when we write our range of values, I'm going to write negative 1/3 at the end. Negative 1/3 must be less than X. X goes in the middle. And X must be less than 3. And if you tried out negative 1/3, you would get, this would be 1 1/3. And this would actually be 2 1/3. And this would actually wind up being a positive 1. And when you add these together, 1 and 1 1/3 gives you 2 1/3. 1 and 1 1/3 give you 2 1/3, and 2 1/3. And so it's not going to work for a triangle, but remember, it doesn't have to be equal to negative 1/3, it just has to be greater than. So I know that X is going to be somewhere in between these two numbers.